Welcome to Physics and Rapid YouTube channel. In today's video, I am going to solve PYQ, that is previous year question paper on KSET on the topic atomic and molecular physics. In that, I am going to explain Bohr model of hydrogen atom and the problems related to Bohr model of hydrogen atom I am going to solve. Okay. Yes, let us start with the first question. This is the PYQ of the KSET. Solve the first question. The ratio of the wave numbers of the first Balmer spectral line of hydrogen to the second Balmer line is. Yes, in the hydrogen atom, we have a set of series, that is Lyman series, Balmer series, Paschen series, Brackett series, and Fund series. Okay, so we have rest of the series also. We are going to study only up to 5 series. Okay, in that what they have asked, they've asked about the Balmer spectral line of the hydrogen atom to the second Balmer spectral line. Yes, Balmer line, this is the transition from n which is equal to 2 to n which is equal to 3. That is the transition from n which is equal to 3 to n which is equal to 2. We call this to be a first Balmer spectral line. Okay. Now they've asked the second Balmer spectral line, right? Second is, that is n which is equal to 4 from n which is equal to 2. Okay. So n which is equal to 4 to n which is equal to 2, we call it as second Balmer spectral line. Now, what the question they are asking? The ratios of the wave number. Now, the formula for the wave number, that is 1 divided by lambda, that is the inverse of lambda, that is inverse of wavelength, is nothing but the wave number. Wave number is represented by nu bar. Nu bar which is equal to R infinity 1 divided by n1 square minus 1 divided by n2 square. This is the general formula. So applying the general formula once for first Balmer series and one more time for second Balmer series, you will get the final answers. Now shall we apply? So it is 1 divided by lambda, that is nothing but nu 1 bar equal to R infinity, that is a Rydberg constant, that value is 1.097 into 10 to the power of 7 into 1 divided by year. N1 value is, in the first Balmer series, N1 value which is equal to 2 square minus N2 value which is equal to 3 square. Okay. Now, all divided by nu 2 bar, all divided by R infinity into 1 divided by year 2 square minus 1 divided by 4 square. Right. Now on solving this get cancels. So here you will be having 9 minus 4. So 9 minus 4 is 5 divided by, it is just a mathematics, 4 into 9 all divided by 4 fours are 16. 16 minus 4 is nothing but 12 divided by 4 into 16. Here 4 get cancels. Now I'm going to rearrange the terms. It will be 5 divided by 9 into 16 divided by 12. So it is, we can cancel it. It is 4 threes are and 4 fours are. Now after simplifying, I'm going to get 5 fours are 20 divided by 9 threes are 27. So 20 divided by 27 is the right option. But here none of the option matches. In the KE, in the result sheet, they have given it to be a grace marks and they have given the correct option to be a B option. But the proper method doing this problem is this method, and this is the analyzing the problem. This is the way to analyze the problem, and this is the solution for this problem. But in the result sheet, they have given option B to be the right option. Okay. Yes. Let us proceed with the next question. What we have in this question, the ground state energy of the positronium is. Now, positronium consists of a electron and positron. Okay, one electron and positron. Here, electron is negative in charge and positron is positive in charge. What they are asking? They are asking the ground state energy. Now, but these two will be having the same masses, that is the mass of the electron and the mass of the positron is one and the same. Now, what is the formula for ground state energy of the hydrogen atom? Yes, we know, right? The energy is nothing but minus 13.6 electron volt divided by n square. This is the formula. But most general formula is E, which is equal to minus m into z square into e to the power of 4 divided by 8 times of pi into epsilon naught square n square into h square. So after substituting the mass, z value and the charge of an electron, epsilon naught value and the h square value, that is 6.63 into 10 to the power of minus 34, we are going to get the value to be equal to minus 13.6 electron volt. This is for the infinite mass. The formula is for the infinite mass. Now they are given to be a positronium. For positronium, what will be the formula? We will see. This is for the infinite mass. Okay. Now for the positronium, instead of m, we will get the value to be equal to mu. That is mu, I am going to tell for a while. I am going to write the rest of the terms as it is. Yes. Now what is this mu? Mu is nothing but the reduced mass. Okay, how to find this reduced mass? Reduced mass formula is nothing but here in this picture it is mass of the electron into mass of the positron divided by mass of the electron plus mass of the positron. As I told, mass of the electron and the mass of the positron is one and the same. So it will be me square divided by 2 times of me. Me and one of the Me get cancels. Now the reduced mass mu, which is equal to Me divided by 2. So instead of mu, what you got? That is energy E, which is equal to minus Me divided by 2, and the rest of the terms remains same as it is z square into e to the power of 4 8 pi epsilon naught square n square into h square. Okay, now this is the same formula as this formula, right? Only extra thing is in the denominator we have 2. So what will be the energy formula if we compare? So the energy formula, which is equal to minus 13.6 electron volt divided by 2 into n square. Yes, this is the formula for the ground state energy of the positronium. Now ground state they are asking, so what will be the n value? If n, which is equal to 1, we call it as a ground state, right? So energy, which is equal to minus 13.6 divided by 2 into n square, that is 1 square will be 1. So if I divide, it will be 2 ones are uh, 2 6 are 12.1, it will be 6.8. The solution is minus 6.8 electron volt is the solution. So which is the right option? Option A is the right option. I hope everyone understood this solution. We are moving to the next problem. Now what is the next problem? Yes, let us solve the next problem. Ionization energy for hydrogen atom initially at n, which is equal to 3 excited state. So the same formula we are using again. So what is the energy of the hydrogen atom? So energy of the hydrogen atom, which is equal to E, which is equal to minus 13.6 electron volt divided by n square, right? So instead of n, what they are asking uh, n, which is equal to 3 excited state, that is value of n, which is equal to 3. So energy we are getting to be equal to minus 13.6 electron volt divided by 3 square. So 3 square is 9. On solving, I am going to get the solution to be equal to minus 1.51 electron volt. Now they are not only asking the energy, they are asking the ionization energy. Now what is this ionization energy means? energy at n which is equal to infinite minus energy at the given state. Okay, so the given state is 3. So energy at infinite means if we substitute for the value of n to be equal to infinite, minus 13.6 electron volt divided by infinite square will be 0, minus of E3. This is the value for E3. So E3 which is equal to minus 1.51 electron volt. So minus of minus it will be plus. Plus 1.51 electron volt is the right answer. So which is the right option? Option D is the right answer. Now let us proceed to the next question. What we have in this question, the ratios of the frequencies of the first line of the Lyman series and the first line of the Balmer series. In the first question only, I have explained hydrogen atom. We have a series that is a Lyman and the Balmer, Paschen, bracket, and the P-fun. So, what they are asking here, a Lyman series, the frequencies they are asking. For a while, so the ratios of the frequency, the same formula we are going to use, that is the wave number or the wavelength formula, 1 divided by lambda which is equal to r infinity into 1 divided by n1 square minus 1 divided by n2 square. So this is the formula. Now instead of wavelength or the wave number, what they are asking, the frequency. Now we know that frequency is nothing but c divided by lambda. Frequency and lambda is inversely proportional to each other. Now can I write, instead of nu divided by c which is equal to 1 divided by lambda, or 1 divided by lambda which is equal to nu divided by c in this formula? Yes, now instead of 1 divided by lambda, what you get, nu divided by c into r infinity into 1 divided by n1 square minus 1 divided by n2 square, right? Or I can write the frequency which is equal to r infinity into c, that is the speed, into 1 divided by n1 square minus 1 divided by n2 square. So this is the formula we have. Now Lyman series is the first series of the hydrogen atom where n which is equal to 1 and n which is equal to 2. The transition is from n which is equal to 2 to n which is equal to 1. We call it as first line of Lyman series. First line of Lyman series. Now it is easy. The ratios of the first line of the Lyman series to the first line of the Balmer series, as we know, the first line of the Balmer series is nothing but n which is equal to 2, here n which is equal to 3. So it is from 3 to 2. This is nothing but the first line of the Balmer series. Yes, now substitute. So frequency 1 which is equal to r infinity into c, instead of 1 divided by n1 square it will be 1 square minus 1 divided by n2 square it will be equal to 2 square. Okay, all divided by nu 2, here all divided by r infinity into c, 1 divided by 2 square minus 1 divided by 3 square. Okay, so here r infinity into c, r infinity into c, it is one and the same, it get cancels. Remaining is take the LCM and solve. Previously as we did, it is LCM is 4 into 4 minus 1, it is 3. So all divided by, here it will be 4 into 9, uh, 9 minus 4 it is 5. Okay, 4 get cancels. What is the remaining? 3 divided by 1 into 9 divided by 5. The solution is 9 3s are 27. 27 divided by 5 is the right answer. So 27 by 5, where we have option A is the right option. Yes, I hope these questions are clear to you. Let us proceed to the next question. What we have in this question, 10 to the power of minus 23 angstrom, that is, it is not an angstrom, it is ampere meter square, is approximately equal to. So 10 to the power of minus 23 ampere meter square, it is approximately equal to 100 Bohr magneton or 1 Bohr magneton, 10 to the power of minus 3 Bohr magneton, or 10 to the power of 3 Bohr magneton. So Bohr magneton, it is given by the formula, it is represented by mu into B, it is given by the formula E into h cut divided by 2 times of m. This is a charge of an electron. H cut can be written as E into h divided by 2 times of pi into 2 into m. So h is, as you know, the value is, it is a Planck's constant, 6.16 to 10 to the power of minus 37, and this pi is a constant value and 4 is a constant, and m is also, it is a mass of an electron. After substituting in the sense, that is charge of an electron is 1.6 into 10 to the power of minus 19 coulomb, and Planck's constant is 6.63 into 10 to the power of minus 34 joule per second, and here 2 into 2 into 3.142 into mass of the electron is 9.1 into 10 to the power of minus 30 1 kg. Okay, so after substituting these values, you are going to get a value that is nearly equal to, I have calculated, 0.9 into 10 to the power of minus 23. So this value and this value is one and the same, right? So this value is nothing but mu b. Mu b is 1 Bohr magneton. So option B is the right option. So on based on the Bohr atomic model of the hydrogen atom, it comes under atomic and the molecular physics. Under this, they have asked 5 questions in the previous year question papers of a case set. Few more problems related to this topic I'll be solving, which was asked in NET and other competitive exams. Thank you for watching. For more videos, you can visit my YouTube channel, that is Physics Unwrapped.